the java.util.function package full of interfaces, right? It is full of the function interfaces. Okay. There are a total of 43 functional interfaces. Okay. There are 43 function interfaces in this package. Okay. So yeah, because a lambda expression is something, for a function interface, you can always write a lambda expression. And it is when we write a lambda expression, what is important to us is the method signature. So most commonly found method signatures. Okay. See, how do you look at a function? How do we look at a function? A function type. If I look at a function type. Okay. So what is a function? I'll say, okay, a function can be looked at as something. Okay. It's some kind of a box. Okay. Which is taking inputs and can return one value, or maybe not be returning a value when we say return type void. Return type is void or returning single value. It can have parameters, so that's the inputs. Okay, fine. So different kinds of inputs and different kinds of return type. Based on this, we have different kinds of functional interfaces. Okay, fine. From the primitives point of view, primitive data types point of view, your parameters here or the return, the types which we use, we have primitive types and we have the reference type. If it's a reference type, I can take the help of generics to not hard code the type. Okay. See, when I said consumer of E, it doesn't hard code that it should only be used for account. It can be used for any type, right? If it's a collection of string, then I can have a consumer of string. Use consumer only for strings. So the function which I have to write is a function. When I'm writing a function, a consumer is a function which can take a string and do some processing on that. Fine. Not returning a value, but doing something with it. Consumer return type void has one input. Right? So we can write a function for this, but we also take care of the primitives also. It's not only generics we have to use. It's not only the reference type we have to use. We also have to use the primitive types. We would like to process based on the primitive types. So as far as primitives are concerned, the most commonly used primitive types which have been covered here are int, long, and double. We understand float, no one should be using, right? It's not a precise thing. And we know the precision level of a float is very bad. So if at all we have to use a floating point type, use double, don't use float. Okay, and 32 bits and 64 bit. So we have the int and the long. Okay, some places, yes, boolean may also be useful to us. And so otherwise the other primitive types are always in terms of int, right? Byte, short, char, right? They are nothing, but they're always going to be promoted to an int type. So we have the various kinds of methods which involve int, long, double, and the generic type. When it is generic, it is about a reference type. Right? So one thing is, let's look at the various kinds of, what are these 43 function interfaces? Right? We can look at the java.util.function package. So we understand all the common types of functional interfaces, the standard functional interfaces. We can actually categorize them. Okay, these function types can be categorized. Okay, the standard function interfaces. So one type is, I'll say we have a type called consumer. So if it's a consumer type, then what is a consumer? Takes input, returns void, doesn't return a value. I'm consuming it. Okay, methods returning void but taking inputs. Okay, fine. There's also one thing which is not in the java.util.function package, but for completeness sake, you can take this one more functional interface, but it has been there right from the beginning in Java, right from 1.0. There's also a kind of a function which doesn't take any input and doesn't return a value. Return type is void, parameters, no parameters. Okay, and for that, if you want to use even represent that kind of a function, we have something called runnable. Right? So we have, so there is something called runnable also. So no type parameter, anything involved in this. Yes, runnable. What is it? Oh, it has a method called run without any parameters. Return type is void. So that's a runnable interface. It's a function interface. So if someone wants to write a lambda expression for a runnable, right? And either a single statement or maybe a block, but not having a return, okay? Not having an expression to be returned. That would be a runnable object. Fine. But if I have to write a consumer kind of a thing, oh, we have how many consumers? There are 5 kinds of consumers for us. Okay, in the consumer category, there are 5 objects, 5 function interfaces. Consumers are 5. Fine. Let's discuss. So, okay, a broader category. Let me just show it here. Fine, and then we'll. So one is runnable. Fine, that's fine. That's no input, no output. Another one, only input but no output. Return type void. We'll call it as consumer. Fine. Another one, it takes input but always returns boolean. We have seen that. Predicates. Okay. Consumers, right? Predicates. Fine. Then no input and giving you some output. Then that would be a suppliers. So we have a category called supplier category. There are no input parameter to such methods, but they are returning some value to us. Okay, returning value. Okay, that's a supplier. Fine. Then, yeah, and then the more general form takes input as well as returns a value. That's what we call as a function. Okay. So function is having input as well as the return value, and takes parameters and returns a value. That's what we call as a function. And among the function, if the type of input and the type of value returned matches, fine, we call it as an operator. Fine. Oh, there are 2 categories of those operators. We say unary operator or a binary operator. So it's a category of the function itself, fine, where we say unary operator as well as the binary operator. Okay, fine. So if we categorize them like this, yes, we'll get all the 43 function interfaces. There are 5 in this category. Predicates, I think, are again 5. No, so predicates are more. 8 predicates here. Yeah. and suppliers will be 5. Okay. Okay, there are 4 here, 4 here. Okay, so how much is it? 43 is the total, right? So other than these 4, 8, that is 8 plus 8, 16, so 26. It should be 17 or 18. Either 17 or 18. We will check that. Right? And let's look at these. Right? What are all these function interfaces? Okay, the 43 function interfaces. So it's quite simple to remember if you just go by this return type and this. The category is based on the types, basically method signatures, various method signatures which we have. Okay, so let's start with the consumer category. Yeah, what are the consumers? Okay, we'll look at to the abstract methods. We are the method signatures involved in each of them. Okay, so there are 5 of them, I said, right? Okay, so one is simple thing which we have already seen, that's a consumer of some type T. Okay, it's okay. If it's a consumer of T, what's the method we are having? I'm just listing the abstract method only because they may have default and static methods as well, right? Each of these function interface. So currently looking at only the abstract method. Okay, so public method return type void, it's a consumer. Method name is always going to be accept. All consumers, the method name is accept. Parameter here 30. Okay, given an object, fine, this is what we have already seen. Okay, fine. Other okay, now other consumers, right? So one is a consumer of T, other is the int consumer. Fine, I'll just, okay, so if I give it for int consumer, fine, I'm just giving the method for the int consumer. Name of the method is public method, returns void. Name of the method is accept. Parameter will be int. Okay, fine. Just like we have the int consumer, okay, we have the long consumer and double consumer. Right? Deals with primitive types int, long, and double mainly. Okay, fine. So these are the 4 function interfaces. One more, there is a by consumer of T comma U. What's a by consumer then? Of T comma U, return type void. Method name is always going to be accept. Then I'm not shown for this because only what changes here is this. Find long and double. Okay. And for by consumer, yeah, 2 inputs. But return type is what? That's a whole. Right? There's also a by consumer. Fine. So 5 consumers. Okay. Next one is the predicate. Yeah. Okay. Let's go for the predicates. Yeah. Which are the predicates we have? We have seen a simple predicate of T. Okay. Method name is always going to be test. All predicates, they have the method name as test. Parameter will be T, right? So given an input, yes, given something, fine. And similarly, we have the int predicate, long predicate, and the double predicate. Okay. Fine. I'll give for the int type, and method name is test, takes int as a parameter. And similarly, the other two things can be there. Okay. There's a by predicate, by predicate of t comma u. Yeah, I think predicates are also 5. Yeah. So what is this by predicate? Has to return boolean, method name has to be test, and t. Okay, 2 parameters. It's a by predicate. Okay. We even have a supplier now. Yeah. Again, this is suppliers are 5. Okay, this is going to be 5. We have the supplier of type t. Okay, and what's the method in supplier? It would return t. It's returning. Supplier means no input, only return value. Okay. So name of the method is get and no parameters. Okay, method name in supplier is get. Okay, and similarly we have the int supplier, long supplier, we have the double supplier, and we even have one more, the boolean supplier. In case of supplier, yes, boolean also has been covered. Okay, public returns int, name of the method is get. Similarly, long, double, and boolean. And each of them has a similar method. Method name is test because it's a supplier. Okay, fine. Let's look at the function type now. Okay. Yeah. Okay, functions. Now, a simple function. So now we can go for a function of t comma r. It's a simple function. R is my return type basically. Right? So what's the method you'll have? Okay, here method names matter. Okay, method name are not always the same, though they will always start with something called apply. Okay, method names. Let me put the method names, right? Method names are apply, apply as int, apply as long, or apply as double, right? Depending on the return type. So it all depends on the return type. Return type is generic, it's apply. If it is return type is int, it's going to be apply as int, apply as long, apply as double. Okay, and so that's a general statement for the method names. Okay, so we have this function which says apply. Oh, I have put the method name. I have not specified the return. Return type is R. Method name is apply. Parameter is T. And that's the input. And exactly on similar lines, we have the okay. So we will have what? Input and output, right? Input being So we may have a, okay, if the input is a primitive, right, it would be called, so what's the input? Based on that, you will have the cat parameter. Input is int. So, okay, you want to say int function of R. Int function of R. Okay, what's the method name? Public method returns R. Name of the method would be apply. Parameters are int. Okay, just like int function, we also have long function and we have the double function of R. Okay, fine. So fine, there are three of them. Okay, int function, long function, and double function. So input is a primitive, int long or a double returns some reference. Okay, fine. So function, int function. Okay, fine. Then we would have input as primitive, output as primitive. So we have something like int to long. Okay, fine. I'll first put the method for this and then I'll list the other. There are total 6 of them, right? Because we have 3, int, long, and double. So from int to long, from int to double, right? So long to int, long to double. Okay, double to int, double to long. Okay, so all those, so 6 combinations, right? So if it is int to long function, fine, the method returns long, and therefore what's the method name? Parameter will be int. Depending on the return type, the method name is there. Your method name, fine. Names are either apply, applies int, applies long, applies int. For all functions, that's what it is, right? Okay, return type, fine. So these are nothing but functional interfaces to represent all kinds of functions, right? So yeah, what are those 43 of them, right? So int to long function, okay, and I'll list the others here. There will be total of 6. Okay, so from int to double, and we'll have the long to int function, we have the long to double function, and we have the double to int function, and we have the double to long function. Okay, and so total 6 of these, and later we'll just count them. We need that count of 43. Okay, okay, so we have the just recollect something which is for the consumer. There are more consumers. Actually, there are 8, not 5 consumers. I'll just go back. Okay, just recollect that. Consumers are going to be 8 and not 5 of them. Okay, what are the others remaining? And the other remaining consumers are obj int consumer, obj long consumer. So it says obj int consumer of some type T, obj long consumer of some type T, and obj double consumer of some type T. Okay, fine. The method signature I'm giving for the first one. Fine. Return type is void because it's a consumer. Okay. Method name is accept because it's a consumer. Okay. Parameter, there are two. First parameter if, and second parameter int. So that way. So total of 8 in the consumer, not 5. Okay. Now that count should be fine. Okay. 8 consumer, fine. 5 predicates, 5 suppliers, and that comes out to be 18. Okay. Function should be 17. Okay, there'll be 17 of them. I will just list them. Okay, it's not over yet. Okay, fine. So fine. Function one is fine, from reference type to reference type, the generic one, T to R, and that's the most generic one. Okay, then from okay, then we had the one from primitive to primitive. Okay, from input is primitive, returns reference type. Right? Next was from primitive to primitive. Okay, from one fine, 3 of them, 3 primitives we are considering. So we had total of 6 of those. Okay, now what we are looking at is, okay, so this is apply as long because into long. Yeah, next one. So next will be, what's the other combination? To int function, to long function. Now return type is a primitive. Okay, function. Okay, fine. Public method returns int. Okay, I'm giving for the first one. And what's the method name? Because return type, it all depends on the return type. Okay, parameter is the T. So given a reference, I'll give one of the a primitive type. So that category is also there. Okay. Okay. Fine. So input is a reference type, output is a primitive, or input is primitive and output is a reference. I think we have covered all of them, right? Okay. Next is the by function from, okay, 2 inputs, 1 output. Output is always going to be there. So public method returns R, name of the method will be apply, parameter will be return type is R here. Yeah. Parameters are T and U, 2 inputs. Okay, fine. Now 2 inputs within the reference is primitive types. Sorry, yeah, where I think 2 int by function of some type T comma U. Yeah. Fine. So 2 int by function. Same way there will be 2 long by function. Fine. The return type is primitive but takes two inputs. Fine. Like TUR, that is returning the reference type, and it's taking two inputs T and U but returns so two double of T comma U. Okay, these are the three things I'm just giving for the first one. Fine. And then the next thing we have are the subcategories in this, which are the operators. We have the, okay, how many functions? Can we just total them up? 1 plus 3, 4 plus 6, 10 plus 3, 17, right? So this is 17. Okay. Okay, yeah. What remains is 8. Okay. So we have unary operators. Okay. So that will be 4 of them. We have the binary operators, and that's going to be 4 of them. Okay. Which are the unary operators? Input and output type are same. So name of the method is going to be applied. Depends on, sorry, it always depends on the return time. Okay, so for example, yes, we have the unary operator of some type T. Okay, so what's the method we have? Returns T, name of the method will be apply. So it has single type parameter. Okay, the input is also T. So input output type is same. Okay, same way we have the int unary operator. Fine, long unary operator and the double unary operator. Okay. Fine, I'm giving for the int type, return type is int, method name is apply as int, parameter is the int. So single input. And now if you look at the binary operators, right, two input will be the case, right? So if I say, yeah, so here is what we call as a binary operator, the generic one of some type T. Okay, so only one type parameter will be there. Public method returns T, name of the method is apply, parameter is going to be two inputs. Okay, then there's a int binary operator, long binary operator, and the double binary operator. Okay, three of those, and for the first one I'm giving, right, parameter two integers. Okay, fine. So we get a total of 43 function interfaces. Right? So Java util package is this. But these function interfaces, they represent a function type, and this is what we find being used in many places. So there are other packages which always are using. Wherever some function interface is there, we would rather use these ones. Okay, we have already seen consumer being used in the for each. We have seen the int function also, right? Int function taking input as int, returning some type. So there it was an array type. The toArray method on the collection. We have seen the predicate being used. Remove if method. Fine, clear. So these are the types we should know. These are just based on just the method signatures. These different categories, most commonly used method signatures. Two input, one output, and all such things, right? What type of input, what type of output? If it is a boolean, we'll say this is a predicate used for testing. I'm going to get a, so remove if, yes, that can be. So conditional checks, that's predicate. Okay, fine. So clear 43 function interfaces. Okay, fine. So what we have done is we have looked at all the 43 function interfaces. I think the way we have grouped them, it should be easier to remember. Fine. And gives a good idea, right? What it is. Okay. And so, yeah, so next what we'll be looking at is, this is function interfaces. There are some new, okay, there are some. So yeah, I'll put the next thing, right? So next is about, okay. From the java.util package. Okay, these again, I can put the names here. Okay, we have something like okay, there's one thing called optional. There's a class called optional, it's a generic one. We have something like int summary statistics. Okay, and since it's for int, it will be available also for the long and the double. Okay, and we'll see some more of the java.util package. And these are all something which are going to be useful before we go to the streams. Okay, streams is the important thing which we would like to go. Okay, but before that, yes, there's some preparation which we have to look at. Oh, another one to be looked at. Okay, we would like to also look at the methods of comparator. There are a lot of static and default methods added in comparator from Java 8. We have used one of them, one or two, I think we used it. Right? We saw natural order, reverse order, such things. But the other things, but they actually were dependent on the java.util function. Okay. So I didn't cover the other methods earlier, and in the comparator interface. So it's, it makes creating comparator very simple. When you'll see how simple it becomes. But before I can make it very, very simple, we'll also have to cover another topic, which is method reference. So method reference and constructor reference, this is something which we'll have to look at. And so tomorrow I think we'll start with this. Maybe we'll first look at this references, okay? And then we'll look into the other things. So method reference, constructor reference. I'll just give a very quick example of just about one single thing here, okay? Okay, by using a method reference, okay, this code which we have written over here, this line, okay, it would change to, okay, Read it. See, if you read this, it says, okay, get me all the values from the map, and for each of those, call the display method of the account. Right? But we'll have to understand that's a method reference, how that method reference comes. Okay. Okay. So instead of writing a lambda expression, you may be using a method reference or a constructor reference. So there are places where we might be able to use it. Okay. I'm commenting it out today, but yes, and that's for tomorrow. Okay. And small changes. Yes. Okay. Fine. So any questions? Yeah.
No, sir.
Okay. Thanks for meeting tomorrow. Have a nice day.
Yeah, sir. Bye.
Bye.